Okay, so we talked about the effect of enzymes on activation energy, but you might be wondering, like, well, what is an enzyme physically? Like, what does it look like, or what is it actually doing? How does it lower this activation energy? So let's take a look at this drawing of an enzyme. Now, of course, these enzymes are big complex proteins, so this is a simplification, but it does show the key things that we need to know. An enzyme serves as a location for chemical reactions to occur. So this is a picture of an enzyme called sucrase. And one thing you notice is that sucrase has an active site. So the active site is where the reactants are going to bind. So in this picture, you can see that what's binding to the enzyme is called the substrate. Substrate, in this case, sucrose, but it could be something else. It depends on what type of enzyme we're talking about. The substrate will bind to the active site. A substrate enters the active site. After it enters the active site, the enzyme will help the reaction to occur more quickly, by lowering the activation energy. And then the substrate or the reactants gets converted into products. The products are released and the enzyme is free to be used again. This is another important point about enzymes. Enzymes are not used up in the reaction. Enzymes can be used again over and over and over and over. Okay, this is the enzyme here, which is ready to go because its active site is empty. By binding the substrate, we allow the reaction to occur, and then once the reaction is done, the enzyme is ready to go again. So this is normal enzyme function. But there's actually a few different ways that we could actually prevent this function from occurring. So the first thing to talk about is just the word inhibition. So inhibition means stopping something. So enzyme inhibition is stopping the enzyme. And there's a couple different types. There's competitive and non-competitive inhibition. So competitive inhibitors will actually compete with the substrate at the active site. So for example, this is not the substrate. This is something else. This is a competitive inhibitor. And by binding to that active site, the substrate can no longer bind to this active site. So what's happening is the enzyme action cannot occur because the active site is not open. So this substrate will have to go find another enzyme. So competitive inhibitors can slow down enzymatic activity by blocking the enzymes from functioning. That's called competitive inhibition because it's directly competing with the substrate for the same physical space, the active site. There's another type of inhibition which is called non-competitive inhibitors. And non-competitive inhibitors do not bind with the active site. They do not physically compete for the active site. Instead, a non-competitive inhibitor will bind to another site on the enzyme. It's called the allosteric site. And when they bind to the allosteric site, it actually causes the enzyme to change its shape. And when the enzyme changes shape, the substrate cannot bind anymore. So non-competitive inhibitors are also blocking enzymatic action, but they're blocking it in a different way. Instead of directly blocking the active site, they change the active site so that the substrate can't bind anymore. Okay, so if we look at this picture here, you can see in this enzyme, this is called feedback inhibition. So basically, in reaction one, we're starting with A and we're ending with B, and then we're taking B, we're using another enzyme to make enzyme C, or to make molecule C, and then molecule C will bind to enzyme 3 to make product D. But product D actually acts as, let's say, a non-competitive inhibitor on enzyme 1. And when it binds to the allosteric site of enzyme 1, it causes enzyme 1 to stop functioning. This is called the negative feedback loop or negative feedback inhibition. And basically, what it's doing is it's saying, okay, we made enough of the stuff we were trying to make, which is maybe C, and so now we're going to stop making more. So the products of this sequence actually go back and block the initial reaction. That's called feedback inhibition. By going through with all these reactions, we now prevent any more reactions by happening by using non-competitive inhibition.